Well, welcome everybody, and welcome back to the CIB Presidential Seminar Series that we broadcast from Purdue University. As you all know that come May of this year, we are holding the World Building Congress that is going to attract up to 600 and more experts from all over the world, talking about what is the role of the built environment industry in addressing the 17 Sustainable Development Goals. And towards that end, in the Presidential Seminar Series for this fifth session, we are holding panel discussions every week. And these are all interesting topics, and these are all experts in their domain that bring wealth of knowledge and background that the commissions that they represent, the task group that they represent in the panel discussion. So today's topic is the role of industrial construction in achieving the SDGs. And we have a distinguished panel put together again. And we have Professor Kim Hockball, Professor Volkan Özkan, and Professor Mostafa Jelodar. They come from three different parts of the world. And let me give a quick introduction to them before I hand it over to them to make their points, initial points, before we get into the discussion. So starting with Dr. Volkan Özkan, he's from Liverpool John Moores University in the UK. And he's also the commission lead for W121, which is for offsite construction. Dr. Özkan is a civil engineer with a MSc and PhD in construction management. He has more than 20 years of academic experience, has delivered a range of courses in civil engineering and the built environment across various disciplines, and actively contributes to academia, industry, and the professional communities. Dr. Özkan is a senior lecturer in construction management at, as I mentioned, Liverpool John Moores University. He is a member of the Built Environment and Sustainable Technologies Research Institute and the Construction Skills and Knowledge Hub at LJMU, or Liverpool John Moore University. He also serves as a joint coordinator of the CIB W121 Offsite Construction Working Commissions, as I mentioned earlier. His research interests include offsite construction from a socio-technical systems perspective, organizational resilience and agility, maturity models, innovation-based change, capacity building at the individual, organizational, and system level, as well as sustainability. Our second panelist is Professor Mostafa Jelodar from Massey University in New Zealand. And I must point out that it's very early in the morning over there. It's like 5:30 or so. So we really appreciate him taking time and joining us today for this panel discussion. He's also the commission lead for W119, which is customized industrial construction. Dr. Jelodar is the academic lead and an associate professor in construction engineering and management at the School of Built Environment at Massey University in New Zealand. With a background in civil engineering, his research specializes in modern methods of construction and automation in the built environment. He has extensive expertise in offsite construction, transformative technologies, productivity, and innovation within the construction sector. Dr. Jalodar's work focuses on integrating design for manufacturing and assembly, building information modeling and digitalization to enhance constructability, sustainability, and efficiency in construction projects. He leads the Modern Methods of Construction and Automation in Built Environment research group, which drives cutting-edge research and innovation in construction engineering and management at Massey University. Additionally, Professor Jelodar serves as the research team leader for Can Construct NZ, or New Zealand, a $10 million Ministry of Business Innovation and Employment Endeavor research program. In this role, he utilizes advanced modeling techniques and AI tools to evaluate trends in capacity and capability within the construction sector, ensuring the development of robust and future-ready solutions for the industry. Our third distinguished panelist is Professor Kim Hockball from Aalborg University in Denmark. He is the commission lead for W118, which is Clients and Users in Construction. Professor Hogbold is a PhD and senior builder researcher at Build at Aalborg University, where he has worked with construction management and innovation for more than 25 years, with a special focus on the role of the client, sustainability, and whole life costing, including the development of tool LCC BYG. Over the years, he has provided governmental advice to authorities, taught countless students at several different educational institutions, contributed to courses and further training of practitioners in the construction industry, and developed research-based knowledge to improve the built environment. Kim has authored more than 250 publications on innovation and socio-technical change in the built environment and has given close to 600 lectures outside the university, including training of more than 2,000 consultants in the construction industry. Kim has extensive experience in evaluation projects and is, among other things, responsible for the evaluation of the voluntary sustainability class in the Danish building regulations. Professor Hogbold is also a member of the CIB board and chair of the program committee. So with that quick and brief introduction, let's welcome our panelists today. And let me hand it over to Professor Özkan to kick off the discussion. Welcome. Over to you.
Thank you very much, Mark. And thank you very much for the introduction as well. First of all, it's a pleasure for me to be here with all these distinguished panelists and, of course, with the attendees, I would say. Today I'm going to talk about, as you know, site construction in general. I will try to give an overview first, and then hopefully Mustafa will be following. I'm going to share my screen, and hopefully I will just get a reaction from you. Can you see that? Can you see my screen?
It's coming up, yeah.
Perfect, thank you very much for this.
If you could speak a bit louder, Volkan, I think the voice is coming.
Okay then, I hope you can hear me. All right. As I said, my name is Volkan Özcan from Liverpool John Moores University, and at the same time, I'm one of the joint coordinators of W121 Offsite Construction Work Commission. Today, I'm going to talk about offsite construction, sustainability, and building efficiency using offsite construction. So, huge areas, huge topics. What I will try to do is I will try to summarize these within the limited time, and hopefully, I'm more excited about the discussion with, I will say, because the first presentation will be more about just putting some main elements to the table, and hopefully they can trigger some further conversation. Yes, first, construction industry, very brief overview. As we know, we can just call it as the global engine of economic growth, especially covering different areas like infrastructure, housing, and other elements, important for both developed and developing countries, and it is creating a main drive for economies. Having said that, at the same time, construction industry has been subject to criticisms over the years. This has been the main focus of various different reports. As you know, there are lots of different elements related to these criticisms. The main element, of course, low productivity and inefficiency, usually comparing with the manufacturing industry. And as I said, in most of these reports, which emphasize this gap, offsite construction has been offered as a solution, or one of the solutions, one of the main solutions, I would say. These criticisms that I mentioned are usually coming from the nature of construction production, as we can say, because as we know, construction production is a unique type of production when compared to manufacturing. It has multiple dimensions. At the same time, the main elements can be summarized as site-based construction, which is maybe the fundamental element behind all these criticisms. All these projects are one of a kind, again related to site-based production. It includes high-level risks, high-level uncertainty, mainly based on labor work, logistic-related issues, and one of the main pollutants, unfortunately, of the environment. That being said, since we said that most of these criticisms are mainly based on the site production nature of construction, would it be possible to eliminate this? Would it be possible to carry this site production to a more controlled environment? Would it be possible to benefit the manufacturing industries characteristics? In fact, this is the main idea behind offsite construction. Offsite construction mainly focuses on designing, manufacturing, and assembling components in a controlled environment, in a more protected environment, and transporting them to the site. So, which is the main or final place of installation. We mentioned offsite construction. Offsite construction usually is being mentioned with modern methods of construction. For that reason, most of the colleagues or industry thinks that it's something new. But the history of offsite construction goes back to Roman armies. In fact, they were trying to carry the pieces of the forts that they will build up to build them very quickly. Of course, over the time, it has been used in different types of constructions, including Eiffel Tower, interestingly, or in 1855, the first prefabricated hospital in Turkey, I can say. And as we all know, or maybe mainly focused, mainly used after the post-war prefabricated houses to find a solution for the housing crisis. Mainly, if we just look at the construction process, we can just name the main stages as design, construction, and use. But what offsite construction brings is divides the construction element into two different phases, tries to manufacture some of these elements that's going to be assembled on site in, as we said, a more controlled environment, and expands this process in four main stages, as we can know. But why manufacturing? What's the special, or what's the main thing about manufacturing? This is a very basic comparison between construction and manufacturing production. As you can see, manufacturing is mainly based on controlled environments, high consistency levels, low per unit costs, less adaptability, but again, low waste, which is mainly addressing the concerns that was emphasized in these criticism reports, I would say. So, we said manufacturing, we are trying to manufacture some parts, some components of construction, but what we are trying to manufacture, it changes depending on the capacity, it changes depending on the project, depending on the needs, of course. It can be basic components like bricks, like wood, like steel profiles, I will say. It can be assembling them, turning them into panelized systems, volumetric units, hybrid systems, even complete buildings can be manufactured by using offsite construction approach, philosophy, I will say. And recently, with the additive manufacturing being more developed, it is an interesting approach because it can be both used on site and it can be used off-site, and it can be used to develop some pieces that are needed for the construction as well. So from this perspective, of course, the ideal approach between design, manufacturing, and construction should be, again, in traditional construction, to be closely integrated, but offsite construction, because of its nature, it needs this integration more. And once this double-sided feedbacks and integration process is in place, we have these different approaches called, like design for manufacturing assembly, which is focusing on the right design for making manufacturing and assembly processes easier, or design for disassembly, which is, again, I will be talking about in the future slides, supporting the circular economy or recycling of the components as well. Benefits of offsite construction. Of course, in various reports, in various publications, lots of benefits are mentioned. This mind map is just giving you a general idea about the benefits. Of course, starting with the most mentioned ones, efficiency and speed, quality, consistency, cost, of course, improved working conditions, but at the same time, improved sustainability and environmental benefits. And, of course, better integration with digital technologies, because as you may appreciate, the digital technologies or digital approaches we recently talk about or focus on, which are based on Industry 4.0 or 5.0, I will say. These are systems or these are approaches that are developed for manufacturing of industry. So what we are trying to do is we are trying to adopt them, or let me just say in this way, making construction production more manufacturing-based approach of nature allows us to apply these or integrate these technologies better, more efficiently into construction processes. So just to focus on sustainability and environmental benefits as the focus of this presentation is more than sustainability. Yes, mainly offsite construction, depending on the amount of prefabricated or pre-manufactured elements, I would say, we can talk about the reduced, the change in waste element, I would say, and at the same time benefiting from the abilities of offsite construction, which allows us to produce these elements with more accuracy, more consistency. We have the ability to create more energy efficient components, energy efficient models, volumetric units, which are more, which is supporting the life cycle of the construction as well. And of course, carbon footprint. Very closely linked to the first two elements of less waste and more energy efficient construction products. Of course, carbon footprint is one of these elements that is reduced with the offsite construction. Of course, I'm sure that there will be some questions in the next phase about the amount of this. We can discuss the amount of these reductions. Of course, these can change depending on the variables. At the end of the day, as engineers, what we are trying to do is we are trying to solve problems, find solutions, and these problems are based on lots of different variables, which changes the amount or percentages of these outcomes. Talking about sustainability, I'm going to talk about United Nations approach because one of the main elements of these presentations is United Nations Sustainable Development Targets. The main reason for putting this definition is, as you can see, it's not only focusing on environment. The way that we see sustainability is covering people, economy, and environment aspects, which we call as triple bottom line approach. Based on this coverage, based on this approach, United Nations developed some goals, which are developed for a period of 15 years, starting from 2015 to 2030, including different aspects of sustainability and categorized under 17 different goals. What we have is, I'm not going to talk about them in detail because I don't have the time, but what I can say is mainly the slide just shows that these are the main SDGs that are being affected by construction and how offsite construction can offer an better experience or positive results. With the abilities, reducing the number of accidents, improving safety, reducing water usage, more energy efficiency, more installation and integration with renewable technologies, providing a decent work experience for the workers, being integrated with advanced manufacturing and digital technologies, providing less disruption, waste minimization, lower carbon footprint, and reduced land disturbance are some of these elements that support United Nations SDGs from an offsite construction perspective. And some of the barriers of this. I mean, if this is something such a beautiful, something fabulous, why we cannot use this properly? Why we cannot adopt and use offsite construction so efficiently? Some of the repeated barriers, starting with economic barriers, which is high initial investments, because this is a factory-based production. The understanding of, we need to understand that offsite construction compared to traditional construction needs a different financial model, which is one of the main mistakes that we do in the industry. We have technical barriers, which is linked to lack of awareness Unfortunately, I mean, we have this lack of skilled workforce because traditional construction and offsite construction, even though we name both of them as construction, they are different. And typical barriers of construction industry like resistance to change, lack of supply chain alignment, which is one of the most important elements, I believe, to support this productivity or efficiency in offsite construction, regulation, policy-related issues, and of course, awareness. When we look at offsite construction, and especially for the recent dissolvencies or bankruptcies, I mean, unfortunately, we have offsite construction as much as it is being encouraged at the same time. As you know, there's a traditional negative perspective about this. And whenever we have an organization, offsite construction related organization, has an insolvency, it's being, I mean, we see these news everywhere. And again, the reasons for these are being investigated by different researchers. But what we can say is mainly in order to be successful, in order to be efficiently used in offsite construction, one of the main things is the systems awareness. We need to be aware of the interlinks and dependencies of people, process, and technology related domains and how they work together, which is again emphasized by different offsite construction roadmaps recently published, including one of them is from W121, providing some maturity levels to help organizations move from one place to higher, to a more improved, more efficient level. This is a slide that I wanted to include, seeing the questions that was mentioned, that was sent to me. Of course, we said that the offsite construction has better integration with technologies, digital technologies, drones, remote monitoring, smart sensors, all of them are part of these Industry 5.0, Industry 4.0, or maybe as we can name them, construction 4.0, construction 5.0 related technologies. Depending on the manufacturing nature of it, it has a better alignment with these technologies. And we believe that improving abilities, improving maturity to use these technologies will help us to improve the offsite construction's efficiency as well. And as the last slide, I just wanted to put a metrics. I know that this is very wordy, just to give you an idea about the indicator offsite things that was mentioned in the recent offsite construction research roadmap that we developed in the Offsite Construction Work Commission, which is approaching offsite construction as through a canvas of design, manufacturing, and construction phases covering people, process, and technology areas. We can discuss this in detail later on, but I'm aware that my time is already finished. So what I'm going to do is I'm just going to thank you and hand it over to Mark again. Thank you very much.
Thank you, Volkan. Thank you for setting that excellent stage for further discussion. So we'll hold the questions till the very end, but let me move on to President Jalal. Mustafa, over to you.
So thank you. I hope you can hear me clear.
Yeah.
All right. Good. So let me just share my screen. Okay. So as Mark mentioned, I'm from Massey University, and I also lead a research group called Modern Methods of Construction and Automation in Built Environment. I'm going to mainly talk about customization, offsite and industrial construction's contribution to the Sustainability Development Goals. I also hold the academic lead position at the university, but that's more like an admin leadership position, which is non-related. Let's dive into the actual presentation. I would like to just go through it with an introduction and purpose, really. Why do we look at customization in offsite and industrial construction, and why it does matter? just before we proceed, forgive me for my British spelling. I'm sure you guys are used to the American spelling, but so we tend to just use the British spelling. So the traditional construction often relies on standardized, rigid designs that are not customized enough for efficiency, sustainability, or specific end user needs. Offsite and industrial construction is evolving with customizable, prefabricated, and digital-first solutions. And the intention here is to obviously reduce waste, improve efficiency and adaptability, enhance resilience, and longer-term sustainability, which often we think will lead to faster, cost-effective construction. I see some of the UN SDGs or Sustainable Development Goals as being directly affected by offsite construction, and some of them are indirectly affected. So I focus on the four main ones which I think are directly affected by offsite construction. And I believe SDG 9, 11, 12, and 13 are directly affected by offsite construction. Industry innovation and infrastructure, sustainable cities and communities, responsible consumption and production, and climate action are the goals that I see they are directly affected. Just some examples of how this direct effect is taking place. For SDG 9, we're seeing smarter factories, digital twins, optimized processes. For SDG 11, we're seeing adaptive and disaster resilient buildings, ensure longer term sustainability. For SDG 12, we're seeing DFMA, design for manufacturing and assembly, minimizing material waste. And for SDG 13, for instance, we're seeing optimized material use and energy efficiency in construction methods to reduce carbon footprint. This is not the whole picture, but it gives you a glimpse. So we need to ask a general question. And this general question for me is, what aspect of construction should be customized for sustainability? And will offsite manufacturing or customized construction give us that? So that's the question. So the first thing that I'm thinking is the process of design, manufacturing, and assembly. That's one of the things that we are customizing through the process of offsite manufacturing and customization. So what to customize? We are looking at prefabrication and modular construction to reduce waste and energy use. We're looking at offsite production to ensure precision and material optimization is achieved. We're looking at standardized modular elements that can be configured for various uses. And we're looking at BIM and digital twins for lifecycle assessments and performance optimization. This potentially will reduce construction time by up to 50%, minimize waste and disruption on site, allows flexibility in design while maintaining structural efficiency. Now, I'm borrowing these from different references. So, and these are obviously debatable, and we could, there's different sources might have different opinions on this. And to me, these fit perfectly well with SDG 9 and SDG 12 as well, two core main sustainable development goals. So in that effect, what are we doing in our research group, for instance? So MOCAP is the Modern Methods and Automation in Built Environment Research Group. And we are, for instance, for this process of designing for manufacturing and assembly, we're looking at application of augmented reality in offsite construction. And one of the things that we're currently doing is we're looking at what are the some of the tasks that are being done by different systems, whether traditional or whether use of technology, and we're trying to optimize those processes. One of the things that we're doing is we're using AR for precision precision location and precision markup of different facilities within the construction, within the actual building. So we're looking at, for instance, visualizing a precast wall and marking the windows, pipes, sockets, positioning, and installations on that. And we have currently developed a experiment around it, and we are looking at how it can increase or improve productivity. This has been currently done by one of my PhD students, Zhidong Zhu, and one of my colleagues, Dr. Jinan Feng. So we work as a team. The other question, to the same question, we've got other things that we can think about in terms of customization. So what aspects can we customize through the process of industrialization and offsite manufacturing? We can customize the use of smart and sustainable material. For instance, we are using engineered timber more rapidly and more often. We're using recycled steel, low carbon concrete to reduce embodied carbon. We are using bio-based adaptive material for energy efficiency and durability. We are using hybrid systems and components for composite action in structural performance and reduced weight. So these are all the innovations that currently is going into the customized solutions. So these can significantly reduce the carbon footprint compared to traditional materials, enhance circular economy, potentially through recyclability, reusability, incorporate smart sensors for real-time material performance monitoring. And these fit well with SDG 9, 12, and 13. So you can see that these different customizations, if we think about these different customizations, how they can fit within the United Nations Sustainable Development Goals. Again, what are we doing at MOCAB? We are trying to look at optimization of heavy steel beams with cross-laminated timber, CLT systems. And we believe the flooring system is a very integral component of the building. And if we try to look at how we customize that, we can get quite a lot of benefit out of it. So what we're trying to do is we're assessing the sustainability and constructability of these different hybrid flooring systems. And when we say hybrid flooring systems, we're looking at flooring systems which give us the maximum composite action. And I'll talk about composite action in the next slide as well. So in terms of the hybrid system with steel and CLT, for instance, you get the benefits of steel, which is strength, durability, and enable us for long span design. We have the efficiency of CLT as a sustainable, more lightweight material with low carbon benefits. However, we have recently looked into the costing of it. The initial costing is not that beneficial. So sometimes timber, and despite the fact that it is very sustainable, could cost you a little bit more, especially when it's a hybrid product. So yeah, and we're trying to look at different aspects of embodied carbon. And the goal here is to optimize the design. And we are thinking of optimizing design through AI or generative AI, which currently is a hot topic in the sector as well. And my PhD student, Negin Karimi, and Dr. Priya Vishnu, my colleague, and Dr. Kaveh Andisha are working on this. Kaveh is from New Zealand Heavy Engineering Research Association. And we are thinking of different solutions for hybrid flooring systems. And when I say hybrid flooring systems, they come with different shapes and sizes. You can see that they could have composite action. For instance, this system has a structural composite action, which benefits from timber and the application of the steel's structural performance. But this system basically relies on the truss as the structural system, and the timber is just gives you the surface. And so with this system, you see more heavy timber being used. So these solutions will have cost implications, obviously. So again, another thing that we need to think about when we talk about customization is, are we customizing construction processes for waste reduction as well? So what else we can customize through the process of offsite manufacturing and customization? We can use mass customization techniques for adaptable reuse components, end of life, and circularity of waste minimization. We can apply lean manufacturing principles to streamline resources use and supply chains. We can also look at automated and robotic construction methods to optimize efficiency. This will reduce material waste to near zero in offsite manufacturing, improves quality control, and reduces defects in production, and accelerates project delivery while maintaining sustainable standards. And this, again, fits well with with SDG 11 and SDG 12. Now, what are we doing? We're looking at developing component passports for offsite construction and material. So looking at tracking the use, the handover of material from one owner to the next, looking at how stakeholders are passing on information and databases to the next person. So we are trying to capture the information of a component through a product data template or a material passport. And this will enable us to potentially have all the information at the end of life for these material as well. So then we can think about, okay, are we going to repurpose, recycle, reuse, or are we going to urban mine? So this is one of the proposals that we're currently working on. And I'm working with Dr. Wajiha Shahzad and Dr. Vishal Kumar. So within this project, we've just recently recruited a PhD student who's fairly recent. And we're looking at different themes which could be used in the material passport. So we're looking at how we can use shop drawings or existing building information model templates to create the material passport, how that can integrate within the workflow, and who will have ownership, who will have responsibility and liability. Another piece of work that we are currently doing in the research group is we're also looking at optimizing the supply chain management. And we're looking at the supply chain process as a multi-objective problem. So, we're looking at potentially using some optimization techniques, a bit of operations research. So waste, time, and cost are our main objectives. Currently, we've developed a systems dynamic model to assess the impact of critical factors in offsite construction supply chains. And we are playing with simulating those factors and trying to see if we can optimize waste, time, and cost. Because obviously, in order to sell any solution, the first thing that the client will ask you, how much it's going to cost me. So yeah, that's one of the, and this work is being done by Sanaz Nisar Nobari and Dr. Wajiha Shahzad and Prof. Monty Sutrishna that we're working together. The other thing that we also need to think about, again, in regards to the general overview or the question of what aspects of construction should be customized, we've got lots of digital tools now. Digital smart construction technologies can also help us in that customization space. So building information modeling, digital twins, AI and generative design, and also 3D printing is very big now that can be used in that digital and smart construction technology space. This will allow precision lifecycle analysis to reduce long-term carbon impact. AI-driven designs minimize excess material usage. 3D printing optimizes material usage and allows for bio-based alternatives. Generative AI is now really big, and if we can harvest it, we can now think about generating designs or alternative solutions very rapidly and with minimum amount of time. So we need to think, and we need to think how we are training the next generation to use these tools as well. So again, that fits well with SDG 9, 12, and 13. So what are we doing about this? At the moment, we're looking at optimizing construction efficiency through enhanced practices. This is another PhD project, and we're looking at offsite and BIM integration in New Zealand. We've noticed that New Zealand is a very small construction industry, and uptake of advanced technologies is quite difficult. So we looked at different challenges and also strategies of integration for offsite and BIM integration. And this piece of work is about that. And we've got some really good recommendations coming out of this piece of work, and things are being published rapidly with this. So other considerations, as I said throughout the whole presentation, any solution will have cost implication. So they should be basically looking at, we should be looking at the whole project cost or the whole life cycle. For instance, if you look at these pictures, you see some traditional connections, you see reversible connections, and they have end-of-life implications. So, for instance, with traditional connections, it's very difficult to have an end-of-life solution for these materials. But if you have a reversible or adaptive connection, you can basically use it, you can reverse it, use it for maybe another building or any other application, adaptive reuse. So, but this comes with a price tag, obviously. So the traditional connection is much cheaper than the reversible connection, and it will need a higher skill set to be assembled. So these are all the different things that we need to think about. So skills, the sweet talk of skills. So we don't lack skills in the construction sector. We do things very, very innovatively, but we need to move away from that mindset of traditional skills. So we need to have a shift from traditional trades to multi-skilled technology-driven roles, growing demand for automation, AI, and digital construction expertise. This is very serious, and I think the whole university sector, the whole tertiary education sector needs to really take a serious look at this. Where are we going with generative AI? It's a challenge, and also it's an opportunity. Integration of lean manufacturing and just-in-time methodologies. Obviously, we've been talking about this for a while now, for years, but with this, with DFMA, we need to have a very deep look at how we're doing this. Expansion of skill sets, construction, manufacturing, logistics, IT, and we also need to look at workforce shortages and drive investment in prefabrication and robotics. Other challenges of the workforce planning. The sector has challenges in mapping capacity and capability. I've tried to do this through an exercise through a project that we're doing currently in New Zealand, especially in the offsite manufacturing and the customized building sector. Because we have got common trades, we've got so many people working in different spaces, and you never know where are they at the moment, and what work they're doing at the moment. So for instance, with prefabrication and modular assembly trades, they can be very common with other manufacturing and automotive sector. So they can be skilled workers which float between different industries. Structural and mechanic trades, common with aerospace, transportation, and heavy engineering. We've got electrical and smart technology trades, which are common with IT, renewable energies, and automation. We've got logistics and supply chain trades, which are common with e-commerce and transportation and warehousing. So these are the people who can float, and they can put our workforce at a deficit or our workforce at a surplus. Just a quick example. This building is an ASB building that is at Auckland waterfront. I don't know if you guys have seen this when you came to Auckland, but it's designed that the funnel at the top works as a natural ventilation system. So the funnel was designed by an architect, but the contractor was a boat maker, because they wanted to make it to bring the exact shape that the architect wanted. So they had to pay a boat maker to create that funnel shape for the top of the building. So you can see that if you're doing customization, sometimes you have to go to extreme lengths as well. There is one more thing that we need to think very carefully about, is energy efficiency and climate adaptivity. Our research group hasn't done much on this, but we are thinking about a proposal there. But at the moment, optimized building envelopes, air tightness, insulated facades, smart responsive facades, and regulated heat and ventilation, integrated renewable energy solutions, seismic resilient modular components, they can help sustainability as well. And they can they can feed into SDG 19, 12, and 13. And they will improve thermal efficiency, reduce energy demand, enhance climate resilience for different environmental conditions, support passive design strategies to lower operational carbon emissions. And this is the team. So this is the team. Sorry, I went a bit extra over time. But yeah, this is the team at different venues, different labs. And we've got a very proactive team, and mixed of seasoned academics and young and energetic PhD students. Thank you. So Mark, I will pass this back to you.
Yeah, thanks a lot, Professor Jalal. That was very interesting indeed, and a ton of research that your team is doing and your colleagues are doing at Massey. Thanks for sharing all of that. Sorry, I had to raise my hand there, but you're sort of running out of time here. So,
Yeah, Mark, sorry about that.
But I appreciate the input. But let me move on to Professor Hogbold now to wrap up this part of the conversation so that we can open for Q&A then. Kim, over to you.
Thank you, Mark. I hope you all see my slides now. Perfect. Thank you, Volkan. This is a picture of a non-industrialized construction starting in around 1160. That's the castle in the background. Just to set off the discussion that I might be a bit more critical towards industrialized construction than the two previous speakers. but hopefully that will generate the background for an interesting discussion about the role of industrialized construction. And thank you, Mark, for inviting me, and thank you to Paul for distributing the Construction Industry Institute report on offsite construction or industrialized construction. I saw, Mustafa, that you were referring to the same report as well in your presentation. And given the fact that I am working on the client and users aspects, I took the liberty of looking into to this report, searching for the use of the term clients in the report. And it's mentioned 12 times during 176 pages. Most of the references are in the appendix related to client requirements in the case studies that are referred to. Hence, it's just another prominent industry business report that has very little focus on the people that are going to buy the products and use the products. And I think we should be more occupied with focusing on who are actually at the end or the receiving end of what it is that we do in our industry. And very often, and I'm not going to let me put it another way. Very often I hear about offsite construction or industrialized construction as the solution to most of the problems that we face in the industry. And I would like to challenge that perception in my presentation and ask ourselves, what role is it that clients and users do play or could play in relation to take up offsite construction, or possibly more the other way around, object towards an increased use of offsite construction? At least that's an intriguing question I think we need to address, because if we are not able to answer that, we may just pursue a line of inquiry that doesn't really suit the needs of those who are going to use our products and services in the end. I will take as a starting point a study I did together with colleagues in France and Sweden some 10 years ago. And it's reported as a chapter in this book by Finn Ørstavik, Andrew Dainty, and Carl Abbott on construction innovation. We applied a theoretical concept or theory called the social construction of technology as a theoretical grounding for the 5 case studies we did in France, Sweden, and Denmark. These 5 case studies varies with respect to the business structure. France as an example of an industry-driven system, and Denmark as a profession-based or profession-driven system. They vary when it comes to business models, they vary when it comes to product scale, and they vary when it comes to the type of clients and users involved in the processes that we studied. I'm not going into the details in the interest of time, so you'll just have to read quickly as I walk quickly through the slides. But we tried to identify what type of innovations were involved in these 5 case studies, and we looked into the interactions with the clients and users. And at that time, when we did the study, the Oslo manual, the OECD manual for innovation measurement, worked with 4 different types of innovations: product innovations, process, organizational, and marketing innovations. And when we look across those 5 different case studies, all 4 types of innovations are actually at play. Not in all of the cases, but together they all cover all 4 types of innovations. And when we look at the type of mechanisms or methods for interacting with the client and users, you can see in the right-hand side of the diagram a list of some of the more prominent methodologies that were applied by the different companies involved in these 5 case studies. So what we tried to do was to use this Scott theory to understand what was happening and what role the clients and users were playing in these 5 cases. And just to give you a very brief overview of the theory and only focusing on the main concept, namely the concept of technological frames that are rules, values, norms, assumptions, testing methods, etc., that guides the way that we look for problems and solutions, and hence what kind of innovation will be the result of the work that we undertake. And having that concept in mind, we might also want to look into what are the configurations of these frames. Are we in a situation where there are no dominant frame at all, which means that we have an open playing field with lots of opportunities, but also a very chaotic process? Or are we looking into a situation where we have one dominant frame, which will then guide the innovations and the direction and trajectories quite narrowly in accordance with the main problem and solution space that is defined by this technological frame? Or are we in a position where we have multiple technological frames at play at the same time, which are dominant and in competition with each other, because that will form innovation patterns that tends to be of the common denominator type. So we will be looking to where they will interact with each other. And our analysis showed that there were 2 main technological frames at play: a frame related to the production or construction, and one frame related to the consumption or use. I'm not going to go into the details of these various elements that are listed here, but just to look at the goals, which is the first line in the table. Namely, in the production frame, we will look at buildings as an end in itself. Whereas if you mainly belong to the consumption or user frame, you would see the building or buildings as a means to achieve something else. So the building in itself or the building process in itself is not really that interesting. It's what we can do with it. So 2 very different perspectives that are at play here, and it has consequences for what are the key problems that these different groups will adhere to. They have consequences for the problem-solving strategies. It has consequences for the requirements that the problems or the solutions need to address, time perspective, etc., etc. You will have to read that at another time. But this gives rise to 3 different constellations or positioning of the client. So if you have the production system and the consumption system, how do the client, who is the one paying for whatever it is we deliver, are the client more related to the consumption or to the production, or take up some kind of intermediate position? And those are the 3 positions I will try to describe now very briefly. And in the first situation, we will look at the client as a user. I've listed a few examples of what kind of client we could think of here. But the client is very, very strongly linked to the consumption phase. And that means that they are focusing on the individual requirements of that particular client. And that means that flexibility and adaptability to meet changing user demands is of the essence. Whereas the requirements is more difficult to generalize and hence possibly to commercialize as well. We'll get back to that in the next, not the next, but the next slide. Looking at the next situation where the client is more linked to the production system than the consumption, I've listed again a few examples here of clients being a standard house manufacturer or private developer for sale. I think, Mark, that you call it tract houses in the US. Well, I think we call it standard houses in Europe. Anyway, what kind of implications does that have for innovation? Well, first of all, a client that belongs more to the production system than the consumption system will be driven by some of the same aspects that Volkan and Mostafa mentioned earlier on, namely how can we optimize the production, how can we reduce cost, waste, etc., etc. And users in this scenario are more likely to be seen as informants, which we can then generalize to some kind of generic user requirements, which can then lead to limited flexibility and adaptability to the specific user need, but on the upside has a possibility of leading to some kind of intellectual property rights, patents, or new technologies that you can then apply and utilize. So there are a very different setup here and very different implications for innovation and of course also for the commercial aspect of innovation. The third situation I would like to describe is when the client acts as an intermediary, not belonging to the production system and not really belonging to the consumption system, but operating in between those two spheres. And in that case, you can just think of the public client, I think, and the social housing company. In that case, we will have a dilemma between being close to the users or having a distant relationship to the users. That will be an issue for the client to think about. Where do I locate myself? How close am I to the users and to the producers as well, of course. It very often leads to innovation processes that are characterized by co-creation or a situation where the client is asked to be a lead user or locomotive, the driver of innovation in the industry, because the client has well, at least ideally have the power and the money to act as a driver of innovation. So those are three different scenarios that could play out depending on where we locate the client in relation to production and consumption. So three main lessons learned. First of all, when we look at these 5 cases, we see a wide range of methods for interaction. We see a wide range of innovations being the result of that interactions. In fact, all 4 types of innovations, according to the Oslo manual, is present in the cases, not in all of the cases, but at the level of all cases taken together. The second lesson I would like to stress is that if we want to understand how change is happening in the construction industry, I think we need to acknowledge that we have these 2 different technological frames applied and being active at the same time, namely production and consumption, and they don't necessarily feel that comfortable with each other. And the third one are exactly these 3 configurations that I just presented: the client as a user, the client as a producer, and the client as an intermediary. That gives rise to different types of agency for the client. It gives rise to different governance mechanisms, and it has different implications for innovation and change in the construction industry. So those were the main conclusions from this study that we did on the 5 cases in Sweden, Denmark, and France. And then what can we learn from those 5 studies in relation to offsite construction or industrialized construction? And this is my last slide, so don't hurry away, all of you. First of all, to repeat something that my co-coordinator David Boyd flagged years back, building is not about building. Building is either a matter of building as an end in itself or as a means to achieve something else. And if we try to sell building as something in itself to clients who are more interested in what it can be used for, they don't give much care to how it is produced. They're essentially interested in the end result and not so much in how we came about producing whatever it was that we came up with. Secondly, I think that industrialized construction or offsite construction is only likely to appeal to a smaller number of certain types of clients and users. It is not likely to be appealing to all clients in all situations. So we need to think more carefully about who is it that would adopt industrialized construction and who will not adopt industrialized construction. And my third and last point is related to the people aspect. In this CII report, people are also mentioned, but people is mostly framed as a matter of the people working in the industry or on the construction side or designing or whatever, not the clients, not the users. And I think if we want to work more with industrialized construction, we need to acknowledge and embrace the needs of clients and users more explicitly. Otherwise, we may risk to have clients and users becoming opponents of industrialized construction rather than proponents of industrialized construction. And with that, Mark, I will leave the word to you. Thank you for your attention.
Thank you, Kim. That was really very interesting, and thanks for bringing out the point about the clients. I think that is indeed a very important point to consider. The CII report that you mentioned, of course, the focus was on the need of the workforce for 2030. So they had their specific focus. So no wonder the clients did not appear very much. But you raised a very, very important point, and I'm sure we'll have a lot of questions coming up on that. So with that said, let me first reach out to the audience present to see if somebody has a pressing question that they want to raise. I have a number of questions that have already come in though, so I can do from my end. So Zahir, why don't we start with you first? You have a question, so please open your mic and ask your question. Zahir, we cannot hear you.
Hello, am I audible now?
Yes, you are. Go ahead.
Yeah. So my question was around client-centered approach and resource optimization through offsite construction. And I think I got my answer through Professor Kim's presentation. So I have no other questions. Thank you.
Okay, great. All right, so Jim, you had a very interesting question that I just noticed. So go ahead and open your mic and ask your question.
Which one?
The very first one in your decades of experience.
Well, yeah, I've had a 30 to 40 years experience in the industry, and on large industrial projects, I think I've never heard anyone discuss sustainable objectives as a reason for a business decision. Offsite construction was always a cost issue and a way to reduce local labor requirements. How do you adjust this thinking with the owners and the large EPC firms?
Who would like to take first shot at it?
Well, let me start out, and then Mustafa and Bolt can continue. I do believe that at least in some context, in some countries, including my own, the cost issue is of course still prevalent, as Mustafa argued as well. But we are seeing an increasing pressure, among others, due to new regulatory requirements both on a national scale and a European scale to reduce the emission of climate gases. And that requires a rethinking of how we do construction. And that force seems to be quite significantly, at least that's what we are facing in the national context of Denmark. And it is forcing clients to reconsider the purchase of technologies, including requirements for how much energy, how much waste, and how large are the emissions of global warming potential gases from the construction side as well, which puts some more emphasis or pressure towards moving production from or on-site to off-site construction, or which is another strategy to reduce the use of fossil fuels for production at the construction site. So that's another strategy that is at play and is enforced by at least one of the largest municipalities in Denmark.
Thank you, Kim.
Mustafa?
Yeah, I totally agree with Jim. You know, throughout my presentation, I also touched on the costs issue. So that's why cost is a big player when, you know, and we look at it as a multi-objective problem rather than just, you know, we want to, because you need to sell it to people who are actually working with it. So if you can't sell it, then there's no point really discussing it. Yes, there is regulations, but for regulations, you still need buy-in because they're always going to, you know, find ways around it or do, you know, some smart stuff to get by. But I think the problem here is if we can achieve some kind of economy of scale, and then, you know, and this is where, you know, one of the thinkings behind it, you know, with scale comes a relatively lower cost, and then there has to be education around the life cycle costs. And it has to be demonstrated to the clients that, look, if you know, and not just clients, to the whole stakeholders involved, and you know, and this is the life cycle cost. And yes, you're paying upfront a little bit more or a significant amount more, but this is what you're going to get in 20 years' time. You know, you're going to get your investment back, you're going to get, you know, reduced carbon emission, you're going to get better energy use. So the discussion is not just a business proposal. It's economies of scale, education, and also life cycle assessment.
Thank you, Mustafa. Volkan, do you want to add something to that, or?
To be honest, I think I'm going to repeat the same things. I mean, I totally agree with the comment because, you know, this is, I think, very similar to the conversations which is starting with the main purpose of every business, starting with making profits, and then later introducing things like ethical issues, introducing things related to environmental concerns. And then these are becoming the larger part of our business. And I mean, the business is trying to include or trying to use them to improve their profits. Very similarly, having sustainability. I mean, before coming to industrialized construction or offsite construction, sustainability is something that mainly that we discuss based on the cost-related issues. But I think as the awareness is increasing in the industry overall, within the whole stakeholders, we realize that, yes, as we mentioned in the presentations, these are all interlinked to each other as a system, which is triggering the others. So once you realize that the things that you do related to sustainability is also helping you in terms of business development or market positioning for others, then you focus on, then you, how can I say, put more emphasis on these. I believe that offsite construction, industrialized construction, however we name it, is one of these tools or one of these vehicles that is helping to become more sustainable. For that reason, I believe that this is a process, or this is a transition process that we'll experience. As we progress, I think we will we will understand how we will learn more about this. And I'm just going to stop here.
Thank you, Volkan. Let's move on, take another question here. Michael, you had a question. Can you open your mic and ask? Michael, can you hear us? Oh, mic isn't working. Okay. All right. Well, so Michael had a question. It says, what critical roles do clients and customers play, and how can their involvement drive real change for more sustainable industrial construction practices? So, Kim, you had already touched upon that, the role of clients and customers. But I think what Michael is wanting to get at, and if his mic opens up, he can perhaps ask to that, is how can we make that change happen where customers are more comfortable with industrialized construction, as I think was raised by one of you, that there's still a stigma associated with industrial construction, and not all clients seem to be on board. But if that's where the tea leaves are going, and that's where we think the industry is going to move, then there's a big part that customers need to be comfortable accepting industrialized construction.
Yes, well, thank you, and a very intriguing question, actually. I just scratched the surface in my presentation and in the work we did over a couple of years together with people in France and Sweden. I think there's still a lot to be said and studied about that, Mark. But before we go too much into details about that, I think we should position industrialized or offsite construction in a proper context and understand that for a very, very large proportion of what we do in the industry is not new buildings. And offsite construction or industrialized production is very much linked to new buildings and less to refurbishment, renovation, or retrofitting, or whatever label we would like to put onto it, because that is still going to be between 80 and 90% of the building stock in all of Europe in 2050. So we need to have some technologies and approaches that can address the refurbishment market or renovation market as well. And if you look at the global construction data across the world, you see a huge amount of new building in developing countries. But when you look at the developed countries, a very, very large proportion in my own country, half of the turnover in the construction industry is related to refurbishment activities. And we don't really have an answer to that. We did a huge program years back on trying to industrialize refurbishment projects, develop some access points, elevators. We've seen industrialized production of terraces to be added to existing multi-story houses, etc. But besides these rather standalone activities, there's not a general trend towards addressing the refurbishment market, at least as I see it. I don't know what you feel about that, Volkan and Mustafa.
I think we are waiting for each other to start the conversation.
Yeah. Volkan, you go this time.
No. As always, I will say that I agree with him. Yes, in the UK, this is one of the things that we also have. Most of the housing stock, existing stock, building stock is how can I say, the old buildings, I will call them. And as you say, the majority of the construction work is around, again, refurbishment, retrofitting. And for that reason, again, retrofitting is one of the major strategies or one of the major research areas that we have. The only thing that I can think about within this is maybe developing some solutions. As you know, we use 3D printing technologies linked to strong laser scanning technologies to rebuild, reconstruct some of the how can I say, listed buildings components. And very similarly, component reusability or can be an option, or that industrialized or offsite construction can be more involved in this retrofitting or refurbishment agenda. Rather than looking at the whole building itself, identifying some parts that can be reused, remanufactured, and maybe developing a business model, I will call, or operational model through this approach would be an option of including this type of approach more into these contexts. But again, some countries have this, some countries have more availability in terms of using industrialized offsite construction. For those, of course, this is a completely different issue, completely different approach. Thank you.
Thank you, Wolfgang. Let me, so Mustafa, I have a special question coming up for you. So I would take that. We have just about 4 minutes left before we need to wrap it up. But you had a question, interesting question that you wanted to ask Professor Deloda.
Okay, I have a question. What are challenges in identifying the factors? What are challenges in integration of the offsite OIC and the BIM? Yeah.
Yeah, it's very difficult to gauge those challenges because they happen at different layers and different levels. And basically, it really relates to the maturity level of where the project is happening. For instance, if there's an organization with higher maturity, the challenges are completely, much less. And then if it's happening in a BIM-friendly environment like Singapore or the UK, the challenges are significantly less. But if it's happening in Australia and New Zealand, we've got challenges of all sorts. So the major challenge is awareness and education, as I would say, and lack of training to some extent. But we have to look at what's happening in the project, where the mandates are, where the codes are. Is there a standard to apply for offsite BIM integration? Obviously, there's not. There's frameworks. And most of these frameworks are based on tacit knowledge and experience, and they're not very conceptualized at the moment. And normally what happens is with offsite components or with components which are manufactured on industrial levels is that you will get shop drawings. So these shop drawings will come to you, and then the contractors will have to use those shop drawings through existing platforms that they have. They might be compatible, they might not be compatible. So these are all adding to those challenges. And then, for instance, a few years back, we've got some shop drawings from China, for instance. There was a problem with how they draw things, and this, we are very different to them, and then we had to find an intermediary. So these were different. Well, obviously these challenges, as they occur, you kind of think about it and try to basically resolve. But challenges are, I would say, at project level, organization level, and governance level, or within the greater industry. And it depends on how regulated they are, how educated the workforce are, and also how much ongoing professional development and training is ongoing.
Okay.
Thank you, Mustafa, for that answer, and thank you, Yushi, for asking that question. I'm going to pick that up upon that, and we have just about 1 minute left, so I'll ask you for your rapid answers, 30 seconds each, perhaps. And the question is, like in Mustafa, you touched upon, getting some drawings from China or some other place, and then, there were differences in your practices and the practices from the acquiring or the procuring country. So that raises a bigger question about, circular economy, and I think all of you touched upon that at certain levels. That from a sustainability point of view, do we have the capability for circular economy to play a role in offsite construction and in plug and play and in retrofitting old buildings? So without the capabilities for the circular economy to really play a role, how do we go about achieving these aspects or these goals? So maybe 30-second response. Do we have the capabilities, and where do we go?
I will start. Just to
Okay,
save
you
some
start
time.
first,
Yeah,
yes.
yeah. I think we still need development on this. We're still not there because this mainly based on supply chain, the power of your supply chain and supply chain alignment, and very similarly things like reverse logistics. Because what you're trying to do is you're talking about a strong supply chain which can work with each other, which can understand each other, as we mentioned in the comment related to BIM, in a way which are interoperable to each other. But at the same, for this reason, for example, in UK, in our region, in some organizations that we talk to, they are trying to upskill the organizations that are in their supply chain to work more efficiently. But at the same time, we also need to understand the concept of circular economy and reverse logistics, so that we can develop this whole model, I believe. But unfortunately, at the moment, I don't think we are there.
Thank you, Wolfgang. Still got 30 seconds.
Yeah, I would say standardization is key here. I mean, for circular economy, if we look at how we do things and standardize things, but obviously architects are going to disagree with me because that's going to be to their detriment. But if we have standards, we have some kind of framework that, this is how these components should be designed, this is the end of life thinking of these components, and how they're going to be used or reused or adaptive reused. So that kind of standardization is missing.
Thank you, Mustafa. Kim, last word.
Only one word, Mark: time. And the word
Time.
time, well, the reason is that we built products that will stay for a very, very long time, which means there will be a long time before they get back into the circle again. And what we're facing now are taking out or using resources from buildings that were erected maybe 100 years ago. And then we think 100 years ahead again. And I think that time dimension is way too long for most of us to grasp and react towards. So it's easier just not to do anything.
Thank you, Kim. Thank you, Wolfgang. Thank you, Mustafa. I really appreciate all of you for sharing your insight and sharing research and the great work that is going on at your organizations. So really appreciate joining this panel and making it a live discussion. So to my audience, again, thank you for hanging there and bringing all these interesting questions. Please open your mics and give them a big round of applause.
Very, very good.
Thank you. Thank you.
And again, we thank our guests and our audience for joining in. And stay tuned for the next week and another interesting panel discussion next Friday. So with that said, thank you all. Goodbye.
Thank you.
Thank you
Good
very
to
much,
see you.
everyone.
Thanks, everyone. Really, really good. Thank you.
Thank you.